Data is supposed to make improvement more objective. That is one of the great strengths of Lean Six Sigma. We measure, we compare, we analyze variation, we identify patterns, and we use evidence instead of assumptions. But there is a dangerous problem. Sometimes the numbers are technically correct and still tell the wrong story. A KPI can improve while the process gets worse. A dashboard can look healthy while customers are becoming more dissatisfied. A project can appear successful simply because the metric was defined badly. And a team can spend months optimizing a number that has almost nothing to do with the real performance of the system. In the previous video, we explored what happens when an improvement project starts by solving the wrong problem. In this episode, we are going one step further. Because even when you choose the right problem, your project can still fail if the metrics point you in the wrong direction. The question is not only, do we have data? The better question is, are we measuring the right thing in the right way? A metric is a representation of reality. It is not reality itself. That distinction sounds simple, but many organizations forget it. Suppose a customer service team measures average response time. The target is under 4 hours. Management puts strong pressure on the team to improve the KPI. A few weeks later, the average response time drops from 5 hours to 3. Success? Maybe. But what if employees are responding quickly with incomplete answers? What if more cases are being reopened? What if customers now need 3 contacts instead of 1? The metric improved. The customer experience may have become worse. This is one of the central risks of performance measurement. People tend to optimize what is measured. And if the metric is incomplete, the behavior it creates may also be incomplete. There is a common management idea that what gets measured gets managed. That can be useful, but it has another side. What gets measured can also be manipulated, sometimes intentionally, often unintentionally. If production is measured only by units per hour, employees may prioritize speed over quality. If maintenance is measured only by maintenance cost, preventive work may be delayed. If purchasing is measured only by purchase price, lower-cost suppliers may create higher total costs through defects or delays. If sales is measured only by revenue, the organization may accept orders that operations cannot reliably deliver. Every metric creates a message. That message tells people what the organization considers important, and people respond to that message. Imagine a warehouse with a target for picking productivity. Management tracks the number of orders picked per hour. The number goes up. Everyone celebrates. But then another indicator starts moving. Picking errors increase. Returns increase. Customer complaints increase. Why? Because the team learned exactly what the system was rewarding. Speed. The KPI did not explicitly say, work faster even if accuracy decreases. But that was the behavior the measurement system encouraged. This is why a good KPI should never be evaluated in isolation. A performance measure must be understood as part of a system. Another reason metrics can mislead is that many organizations rely almost entirely on lagging indicators. A lagging indicator tells you what already happened. Scrap, customer complaints, late deliveries, warranty claims, lost sales, accidents, rework cost. These indicators are important, but by the time they move, the process has already produced the result. Leading indicators are different. They try to tell you what is likely to happen before the final result appears. For example, process capability, preventive maintenance compliance, variation in cycle time, supplier performance, first pass yield, training adherence, process parameter stability, backlog growth, schedule changes. A mature measurement system usually needs both. Lagging indicators tell you where you have been. Leading indicators help you understand where the process may be going. Average values are especially dangerous. Suppose average delivery time is 7 days. That sounds manageable. But what if half the orders are delivered in 3 days and the other half in 11? The average is still 7. Yet the process is highly inconsistent. Now imagine that another process also averages 7 days, but most deliveries fall between 6 and 8. Same average. Completely different process. This is why Lean Six Sigma cares so much about variation. A single average can hide instability, and customers often experience variation much more directly than they experience the average. They do not receive the average order. They receive one specific order. Consider another example. The process has an average cycle time of 10 minutes. After an improvement project, the average falls to 8 minutes. Management celebrates a 20% improvement, but the standard deviation doubles. Now the process sometimes takes 4 minutes and sometimes takes 16. The average improved. Predictability got worse. And in many operational systems, predictability matters just as much as speed. Sometimes more. A process that is slightly slower but stable may be easier to manage than a faster process that is unpredictable. This is why improvement teams must look beyond central tendency. Variation tells a different story. Percentages can also be misleading. Imagine defects fall by 50%. That sounds impressive. But from what to what? From 2 defects to 1? From 2,000 defects to 1,000? Now consider another statement. Customer complaints increased by 100%. That sounds alarming. But perhaps they increased from 1 complaint to 2. Percentages matter. But context matters more. Strong analysis always asks, what is the baseline? What is the volume? What is the absolute impact? What changed in the denominator? This is one of the most overlooked sources of misleading metrics. Suppose a factory reports defect rate as defective units divided by total units produced. Last month, 100 defective units out of 10,000. 1%. This month, 80 defective units out of 5,000. The number of defects decreased, but the defect rate increased from 1% to 1.6%. Which story is correct? Both. The question is which one is relevant to the decision. Metrics are often affected by volume, mix, seasonality, product type, customer segment, or operating conditions. Without the denominator, the story may be incomplete. Another issue is the measurement window. Daily numbers may be too noisy. Monthly numbers may hide important variation. Quarterly numbers may react too slowly. Suppose a process experiences a serious problem for 5 days. If the KPI is averaged over the entire quarter, the problem may almost disappear. But operationally, those 5 days may have created major customer impact. The measurement period changes the story. So when defining a metric, ask, how often should it be measured? How often should it be reviewed? At what level should it be aggregated? And what kind of variation do we need to see? Lean Six Sigma teams sometimes become excited about sophisticated analysis. Control charts, regression, hypothesis tests, capability studies, machine learning. But none of those methods can rescue poor quality data. Before analyzing a metric, the team should understand, where does the data come from? Who records it? When is it recorded? How is it defined? Has the definition changed? Are there missing values? Are measurements consistent? Is the measurement system reliable? Are employees interpreting the criteria the same way? If the data collection system is weak, the analysis may be extremely precise and completely wrong. Imagine 2 inspectors evaluating the same product. One classifies a scratch as a defect. The other considers it acceptable. Now imagine hundreds of products being evaluated across multiple shifts. What happens to your defect rate? It depends on who inspected the product. That is not a process metric. That is a measurement inconsistency. Operational definitions create consistency. What exactly counts as a defect? When does cycle time start? When does it end? What counts as on-time delivery? What counts as a customer complaint? What counts as downtime? Without precise definitions, teams may think they are discussing the same KPI while measuring different realities. Some metrics look impressive but are weak indicators of real performance. Number of improvement projects launched. Number of employees trained. Number of Kaizen events completed. Number of ideas submitted. Number of meetings held. Number of audits performed. These may be useful activity measures, but they are not necessarily outcome measures. A company can complete 50 improvement projects and create almost no meaningful business impact. Another can complete 5 projects and transform its performance. The number of projects does not tell you whether the organization improved. Activity is not the same as effectiveness. One of the most dangerous measurement problems happens when departments optimize their own metrics. Production wants long runs to maximize efficiency. Logistics wants small batches to reduce inventory. Sales wants maximum flexibility for customers. Purchasing wants large orders to obtain better prices. Finance wants lower working capital. Each department may improve its own KPI, and the overall system becomes worse. Lean thinking reminds us that process performance crosses functional boundaries. Local optimization can create global instability. A strong measurement system should encourage cooperation across the value stream, not competition between departments. Before trusting a metric, ask 6 questions. First, what decision is this metric supposed to support? Second, what behavior might this metric encourage? Third, what important dimension is missing? Fourth, could the metric improve while the customer experience gets worse? Fifth, does the metric capture variation or only an average? And sixth, can the data be trusted? If these questions create discomfort, that is useful. It means the metric deserves closer examination. One practical solution is to use balanced metrics. If you measure speed, also measure quality. If you measure cost, also measure reliability. If you measure productivity, also measure defects. If you measure inventory, also measure service level. If you measure utilization, also measure flow. This does not mean creating dozens of KPIs. Too many metrics create confusion. The goal is to prevent one metric from driving harmful behavior. A small set of balanced measures is often stronger than a large dashboard full of disconnected numbers. This is where Lean Six Sigma adds enormous value. Instead of asking only, did the KPI go up or down? We ask, is the change statistically meaningful? Is this normal process variation? Did the process actually shift? Is the improvement stable? Is the process capable? Are there special causes? What pattern does the data show over time? This changes the conversation from reaction to understanding. Without statistical thinking, organizations often react to every movement in a KPI. Up this month? Celebrate. Down next month? Launch an emergency action plan. Up again? Celebrate again. The process may not have changed at all. Only the numbers moved within normal variation. A red KPI creates emotional pressure. Someone wants an explanation. Someone wants an action. Someone wants a recovery plan. But a red number is not automatically evidence of a special cause. Sometimes it is simply variation. Reacting to common cause variation as if every result has a unique cause can create more instability. Teams change schedules, adjust settings, move people, change priorities, add inspections, launch retraining, and eventually the process becomes even more inconsistent. One of the hardest leadership disciplines is knowing when not to react. Metrics should help teams learn, not just judge. A good measurement system should answer questions such as, are we improving? Is the process stable? Where is variation coming from? Are customers experiencing better performance? Are our changes producing the intended result? Is the improvement sustainable? If a metric cannot help answer a meaningful question, ask why you are collecting it. Because every metric creates cost. Someone collects the data. Someone cleans it. Someone reports it. Someone reviews it. And someone reacts to it. Measurement should create insight, not bureaucracy. Think about the KPIs in your own organization. Is there one metric that people work hard to improve, even though everyone knows it does not represent the full reality of the process? Share your example in the comments. These situations are far more common than most organizations admit. Lean Six Sigma depends on data, but data alone does not create understanding. The metric must represent something meaningful. The definition must be clear. The measurement system must be reliable. The context must be understood. And variation must be considered. Otherwise, a dashboard can create the illusion of control while the real process continues to deteriorate. So before asking whether a KPI improved, ask a better question. Does this metric actually tell us what we need to know? If you work with Lean Six Sigma, operational excellence, quality, or process improvement, subscribe to the Lean Six Sigma channel for practical discussions about how improvement really works inside organizations. This series is called Why Improvement Projects Fail. And in the next episode, we are going to challenge one of the most dangerous phrases in problem solving. We found the root cause, because finding a cause is easy. Proving that it is the real cause is much harder. I'll see you in the next video.